Welcome to this example that we are going to do today. I have decided to do a different bearing sheet, mostly done by the land survey students, either the diploma or the certificate. So here is an example of a fully observed made orientation bearing sheet. Today that will be our lesson. I've went ahead and looked at a question, and the question I had obtained some field notes. So here are some field notes where we have a pussy to the cat having a bearing of 240731, and then to N5 having a bearing of 2392951. Then here we have a fluffy from the pussy, that is 1074315. From that we move on to the kitten. So here we have station. So here is the controlling point where our kitten we had observed the ginger, Tom and N1. Then we have, so here the bearings provided to us from the field notes that we were using. And then from the kitten we go ahead to the next control station, that is N1. Then N1 we have the this is the back bearing of the same line. Then our fore bearing to N2 we have 8547 00 seconds. Then from there we move on to N2. Then N2 we have a back bearing here. Then we have a fore bearing to N3. From there we move on to the next field notes, that is from N3 to N2 and N3 to N4. Then from N4, that is the controlling station N4, to N3, then again to N5. So you remember these are the back bearings because that is the value that is observed on the same line of both control stations. Yeah, we obtain our data. Then we move on to N5. N5 again, here we have a back bearing. Here we have again another distance. So from N5 to the pussy, this is where mostly our trick is. Then from N6 to N5 back, then from N6 to N7, and then from N7 to N6, that is the back bearing. Then from N7 to the rat. Then on our last control station, here we have the rat back to N7, then the rat to the trap, and then lastly our rat to the mouse. After having observed that, here we have the datum bearings. So here we have our datum bearings. We were given the datum bearings of this question. So we have the pussy to the cat. So here the datum bearings, these are the correct bearings that were supposed to be there on the field. So these bearings don't have any error of any kind. So from the pussy to the cat, pussy to fluffy, we have the correct datum bearings provided to us here. And then from the rat to the trap, then we have from the rat to the mouse, then we have the kitten to ginger, the kitten to Tom. So this that can be Tom and Jerry. Yeah, something close to that. So here we have the datum bearings, the right datum bearings that we had observed from all these questions. And then the most important thing under the mid. So here we have the mid orientation bearing sheet. So the most important thing that we are supposed to learn Since the observations of the pussy here have been oriented to the cat and to the fluffy, the bearing correction is done separately. So here we do the bearing corrections separately. After having done that separately, then we correct again our data. So from the pussy to N5 in order to determine where our applicable mid orientation of the bearing sheet was observed. So that is something that you need to remember and something that is important. So we are doing this first part separately first. After doing that, then we are going to observe all the other data that we were supposed to do. First thing you draw, this is the solution. So our bearing sheet, it has 6 columns. So on the first column we have the stations, we have the observed values, we have the orientation correction, preliminary adjusted bearings, we have the final correction, we have then our final bearings. As you have remembered what I had said earlier, first thing we start with the data provided from the pussy. So in our stations we write, so from the controls station where we had the pussy to the cat to N5 to fluffy. So here the observed values that we had been given in the field notes section. So this is from the pussy to the cat, the pussy to N5, then to fluffy. So those are my observed values that I am going to be using. So here on the observed value section, you write all that was provided from the field notes. After having done that, after writing all the observed values, you move to our last column, the final bearings. And as we had seen here, we have the pussy to the cat, and our pussy to the cat, the datum bearings, which were our correct datum bearings, that is 24. That is the right datum that we are using. Then from the pussy to the fluffy, we have 107, 43, 20. Those are the right data bearings. And we come here and we put that under the column where our final bearings. So our final bearings are the bearings that are correct. So we have the observed values and we have the final bearings. Those are the final values for both the cat and the fluffy. As you can remember on our other tutorials or other videos, you find the correction, the orientation correction to be applied in order for you to find the value that was correct. So the value that is given to our final bearing here. So you, by the use of a calculator, or you can even go directly by observation, but a calculator will be most accurate. So here we needed to add 0.6 seconds. So here on our last portions, there is where most of the correction is applied. So here we are supposed to add 6 seconds to the data that we have here, 24 degrees 07 31. If we are, that is a correction of 6 seconds, we'll get our final bearings. Then the same is done on the from the pussy to the fluffy. Here we have 107, 43, 16. and here the final bearings was 107, 43, 20. So our correction is applied on the last section where we didn't have any similarities. So our degrees and our minutes, they didn't have any variation. So we were supposed to add positive 4 seconds in order to get the correct final bearing, which was supposed to be 20 seconds. So you come again and you write your value here. After doing that, you use both of the values provided to you on the orientation correction. So that is 0.6 that is 0.6 seconds plus 0.4 seconds. We get a total of there our total will be 10. After getting a total of 10, we divide it by 2 and we get our mean as 0.5 seconds. So that is 0.5 seconds, the value that we are applying on the orientation correction column. So this is the first step on which we were supposed to calculate. After having done that, we move on to the kitten. So our kitten, on this next section, we do it like the normal bearing sheet that we were calculating. So from the kitten to ginger, from the kitten to Tom, and from the kitten to N1, we have the observed values provided to us on our question. So here we had our observed values. So these are the field notes that we were given. So from those observed values, those are the data that we're going to place on the second column here. So from the kitten to ginger, from the kitten to Tom, and to N1. Then earlier we had been given the datum bearings of from the kitten to ginger, from the kitten to Tom. Our datum bearings are the correct bearings that we are supposed to find from the field notes. So these are the data that we are going to apply on the final bearing column provided to us. So from that table, we come and input our values from the kitten to ginger. That is 336, 47, 27, and 49, 57, 19. So those are the two values that we are supposed to compare. We do the same just like we have done earlier here. So we find the correction that is supposed to be applied, and as we can see, our degrees and minutes they are the same, so we don't have any much change there. On our sections where we have our seconds, there is where our correction needs to be applied. So by subtracting both these two values, we'll get a -5. So that -5 is the data that will be used in order for us to subtract the observed value in order to get the final bearing. So by subtracting both of them, we obtain our orientation correction from the same. And then we move on to the next kitten to Tom, the same. So here our values are the same of the second and the minutes, but on our second section here, that's where I have a difference. By subtracting both, we see we need to have a difference of 8 seconds. So by the use of a calculator, that will be illustrated well. So we need to subtract 18 seconds to the 27 second in order for us to get our final correct bearing, which was provided to us from the datum observations. So that is -8. After getting that, we do the same. So we find the mean of both the orientation correction. So -5 plus -8 are divided by 2. After dividing that, we round off our answer, and our answer becomes -0.7 seconds. So that is the orientation correction that will be applied to N1 from the control station of the kitten. Having done that, you come and observe. Here we have our bearing of the kitten to N1, and then on our next table, here we have the observed value from N1 to the kitten. So this is the back bearing of the same line, and our back bearing will be gotten from here. So by adding this is by adding 180 degrees to this value of ours, we'll get our final value as 18. So this is 318.27, but we'll have a difference of the seconds. So this is 18 seconds. So that was supposed to be the data that was supposed to be right, but here we have a deviation. So on this section here, by subtracting both those two, we'll have gotten the difference in the corrections, and our difference there by subtracting that 18, that means our correction needs to be subtracted. So that will be -3. -3 applied to the orientation correction that we had earlier here. So -3 minus -7 will get our next orientation correction as -10 seconds. And then moving to the next, so from the control station N1 to N2, we have a bearing of 85.4700. By adding 180 degrees to our value here, I will have the back bearing of the station, the next station. So here our back bearing was 256.4703, but when we added earlier 180 degrees, our back bearing was supposed to be 256.4700. So we need to correct on the last part here where we have the seconds. So by subtracting that, we get a -3. So that is the data that will be needed in order to obtain our correct back bearing there. So -3 again, on the orientation correction we add from our previous. So -3 minus -10, we get our next orientation correction as -13 here. So that is -13 seconds. We move on to our next part. So from control station N2 to N3, we have a bearing of 182.0530. Then on our next part, so our back bearing here was observed again. So by minusing 180 degrees to this value, the observed value, the bearing of N2 to N3, we'll get our back bearing as 02.0530. But here we had observed a value as 02.0526. So there we need to apply a correction. By subtracting those two, we'll get a +4. That is the data that will need to be applied. So +4 added to the previous orientation correction of -13, we'll get our answer as -9 seconds. So that is the correction on the orientation correction column. And then we move to our next part. So from N3 to N4, our observed forebearing is 162, 37, 17. So this is our observed forebearing. On our next here, the back bearing of the same was observed again, so we need to correct that back bearing. So by adding 180 degrees to our value here, we'll get our answer as 342, 37, 17 seconds. So 17 seconds. That is the correct back bearing that is supposed to be here. But here we can observe our back bearing, the last section. So that is where a lot of data changes. So that was 0.6 instead of 17. By subtracting both those values, our orientation correction will be so we'll need to correct there by a positive by subtracting that is a positive 11. Positive 11 applied to the previous orientation correction was negative 9, so we are going to add that negative 9 plus 11, and then our next orientation correction becomes a positive 2 seconds. We move on to the next part. So from N4 to N5, we had a forebearing of 193, 11, 12. By minusing 180 degrees in order to get our correct observed back bearing, our answer will be 13, 11, 12. So there we have 0 correction, so that value remains the same. That means our next section is correct. So the orientation correction applied on the previous positive 2 will be the same, because we'll add a 0, and that will be the orientation correction applied to our values, our 2 values there. So from N5 to the pussy, N5 to N6. Yeah, then we move on to our next part. So here from N5 to N6, we have a forebearing of 179, 42, 54 degrees. Adding 180 degrees in order to get our correct observed value of the next station, so that is the back bearing, will be 359, 42, 54. But here we can see our last part, we had an error, so that was 51. By subtracting both those two, will get a positive 3. That positive 3 will be added on the previous orientation correction section here. So positive 3 plus positive 2 will have our orientation correction as positive 5. Having done that, we move on to the next station. From the control station N6 to N7, we have a forebearing of 257, 28, 22. By subtracting 180 degrees, our answer will be 77, 28, 22. But here our answer had an error on the last part, so that is 77, 28, 31. By subtracting that 77, 28, 22 by 77, 28, 31, we'll see we need to apply there an orientation correction of that will be negative 9. So by that is negative 9. by adding the previous orientation correction of positive 5 to that which we have gotten of negative 9, we'll get our next orientation correction as negative 4 seconds. And on our last part, so here we have observed from N7 to the right, that's the 4 bearing, we have 313, 40, 26 seconds. By subtracting 180, we get 133, 40, 26. But here we see we had a great error of 34 seconds. So by subtracting those two values there, we have a difference of negative 8 seconds. So our negative 8 seconds will be applied to the orientation correction of our next portion. So by adding 4 degrees plus negative 8, will get our next orientation correction as negative 12, which will be applied to both our values found on the control from the control station of the rat. So by finishing all those orientation correction, we go again. So here we'll start. I can start from our top table. So you can do this in any sequence. So I'm going to add the observed values from the orientation corrections. So observed value from the orientation corrections here. So let me start with the first one. So that is 239, 29, 51 plus seconds. So these 5 seconds. We'll get our answers 239, 29, 56. So remember that. Then on our next part, so from the kitten to N1, we'll add the observed value here, 138, 27, 18 minus 7 seconds. We'll get our preliminary adjusted bearings as 113, 27, 11. And then also on the next part, so the observed value of N2 will add the orientation correction in order to get the preliminary adjusted bearings. Then again from N2 to N3, the observed value will add the orientation correction and get our preliminary adjusted bearings. Again from N3 to N4, I will add, that is 162, 37, 17 minus 9 seconds. So on the calculator, remember to add the 0 minutes and 0 degrees in order for you to obtain the right value. So getting the preliminary adjusted bearing there. Then we move on again to our next part. So from N4 to N5, the observed value added the orientation correction, will get the preliminary adjusted bearing as 193, 11, 14. On our next part, there we have two observed values from the control station. N5 are being oriented. So there the observed value of N2, N5 to the pussy, we add the orientation correction, and also from N5 to N6 we add our observed value with the orientation correction, and we get our preliminary adjusted bearings. Then here we have from N6 to N7, we do the same. We add our observed values with the orientation correction there, and we get our preliminary adjusted bearings. On this last table, we do the same. From N7 to the right, the observed values, we have them here. We add the orientation correction and we get our preliminary adjusted bearings. And then from rat to trap, that is 201 0604. We subtract the orientation correction of a negative, so we add the orientation correction of a negative 12 seconds, and we get our preliminary adjusted bearings. So we get our both of the mouse and that of the trap. So this is the data that we are in great need of. So from our preliminary adjusted bearings, we'll have gotten the two data there that we need to use in order for us to get the final correction. Earlier on the question there, we had our datas. So from the rat to the trap, rat to the mouse, we had the correct datum bearings provided to us here. Remember that. So these are the data bearings that we are putting on our last table, the last final bearing. So there we have those two values there. So those are the correct observed bearings from the rat to the trap, rat to the mouse. So by the use of a calculator, we observe the preliminary adjusted bearings, and we need to find the final correction that was applied in order for us to get the correct final bearings, which we have gotten from the datum bearings. So by subtracting the final bearing to the preliminary adjusted bearing, we can observe the final correction was positive 4 seconds. So that was the data that was added in order from our last part here to be correct. So that is positive 4. Then the same is done. The final bearing of the mouse, that is 318 23 28 minus 318 22, that is 23 22, and we get a positive 6. So we added a positive 6 to the preliminary adjusted bearing of the mouse in order to have our final bearing. After doing that, you add both our two values. So 4 plus 6, our answer, that is 10 seconds, divide by 2, we get our mean as 5 seconds. After having done that, we move on to our next part. So here we had the mid orientation, and our mid orientation was on this part here. So from the pussy to N5. So but on our table here we had already oriented the correction and gotten our preliminary adjusted bearing as 239 29 56. So this was the correct preliminary adjusted bearing of the pussy to N5. So this is where our mid orientation correction is. So from N5 to the pussy, to the cat, to the fluffy. So here is where our mid orientation correction was applied. So from that value, so pussy to N5, we had gotten, that is 239 28 56. Then in order for us to get the back bearing, so that will be from N5 to the pussy, we subtract 180 degrees and our back bearing becomes 29 56 seconds. So this is the data that we are going to use as the correct datum observed, the datum bearing of our mid orientation section. So we come again, so from N5 to pussy, so N5 to pussy, we have gotten our final bearing as 59.2956 seconds. We had calculated earlier the preliminary adjusted bearing as 59.2943 seconds. So in order to get the final correction of both those two values here, we need to subtract. So we subtract the final bearing to the preliminary adjusted bearings, and by subtracting we get our final correction as positive 13 seconds. That is the final correction that will be applied to N6, because we are rotating there, so the mid orientation will be applied again to the N6, because that is the value that is moving from N5 to N6, so that is a positive 13 seconds. And here in our mid orientation, so we'll correct that by rotating upwards and also by rotating downwards using your calculator. First of all, we need to count the number of stations from N5 going downwards. So here we have N6 as 1, N7 and N8. So N7 and the rat, those are 3 stations there. We go ahead by the use of calculator. We divide that, so 13 divided by let me see, so let's again count these stations from here, our stations. So by the use of a calculator, you go ahead and you divide 13 by the number of stations there. That will be 4.333. That is the value that we are applying here. So that is the correct value applied here on this part. So the final correction that we have rounded off 4.33 rounded off, and then we move on our next station. We add 4.33 by 4.33, we get 8.66 rounded off. We get our value as 9 seconds. The same is done in order for us to make sure that we have the correct final. We prove if that value is correct or it will return to 13. So again we add again 4.33 and our answer becomes the same, so that is 13. We count the number of stations found here. So from N5 moving upwards, so here we have 1, 2, 3, 4, and we have 5, and the last 6 stations there. So we have 6 stations from our values. By the use of a calculator, you go ahead and you subtract. So you divide 13 divided by the number of stations to the 6 station and get that is 2.166. That is the value that you're going to you round it off and you input it starting upwards. So that is starting upwards on our first station there. So you add the final correction there. Again you add again 2.21667 by 2.167 and you find the next final correction. You do the same to the next station and you find that will be positive 7 after rounding off. You do the same to n for the final correction there, positive 9. Then you move to the same by adding that, we get a positive 11, and we add the same in order to prove if our final orientation was right. That becomes 13 when rounded off. Having finished that, you move to the final step, our final step of writing our values. So the final adjusted bearings, so that remains the same. So there, that was the final bearing, which was correct. Again, we solve the preliminary adjusted bearing minus plus the final correction, and we get our final bearings of all our observed data. So by adding all the preliminary adjusted bearings to the final correction, we'll get our final bearings of all the data that we have. So by doing that, we'll get all our values written there on the screen. So that will be the right method under the mid orientation section. So that is the mid orientation bearing sheet. Thank you for having me. We have more videos. You can repeat on the normal bearing sheet. So I'll be looking for other questions on the mid orientation, and I will work them for you. So thank you. Remember to subscribe to the channel for more videos and for a better future for you learners. Thank you. That will be all.